Hi, in today's video we're going to be taking a look at this ultimate speed jump pack / USB power bank. Now if this looks familiar, that's because I've already done a video on this a while back, but unfortunately it's now broken. Now the symptoms are that when you plug it in to charge, it will pretty quickly go up the light bars to fully charged. As soon as you try and power it on, this will just drop to dead, back to nothing. The light won't come on. If you try and plug in anything into the USB outputs, they are completely dead as well. Now I don't know if this is a case that because I've not used it, I don't use this for backup on the car because it won't jump start my car. It's just been sitting around idle majority of the time. Maybe the cells have died, who knows, but we're going to try and take it apart and have a look inside and if anything just try and recover the cells if they're any good. Now before we crack on with this, just a reminder, do please check out my sponsor PCBWay. They make brilliant high quality PCBs. With PCBWay you can get high quality PCBs from just $5 for 10 boards. Why not add assembly starting from just $30 for 1 to 20 boards? PCBWay offer a high quality and professional manufacturing service, from prototype to fully assembled boards, flex PCBs and more. Check them out in the link below. So we just grabbed the multimeter here because I want to try and see if we've actually got any voltage on this direct output from the battery. This is what you'd plug in the leads to jump start the vehicle, and we've got just under 10 volts. So the batteries are holding some power, so we are a couple volts down. So that's a good sign so far. That means that, fingers crossed, the cells are not completely dead, and by the looks of it the actual circuitry that runs all the USB stuff has failed. So the next thing to do is see if we can get this open. Hopefully we can crack it open with a spudger. That's looking good so far, certainly for that side. Now I'm not quite sure how many cells are going to be in this one, but hopefully if they can be recovered, we should be alright to reuse them for something other than being inside this battery pack. Now if any of you guys who have already got one of these has had the same issue, do let me know if it's a common fault that they just sort of fail after a period of time. I'm going to be a bit brutal with this because I'm not particularly bothered about trying to get it back together again. We just simply want to get inside, have a nosy and see if we can do anything with it. So it looks like we've got a bunch of screws to remove here, so I'll grab myself a screwdriver and we will whip those ones out. Alright, so we'll just remove these screws. It's like 6 in total, and hopefully that other half of the cover will come off. They're not particularly tight, these screws, at all, to be honest with you, but they're only going to be going into probably be self-tappers into plastic, so they don't want to be over tight, otherwise they will strip the threads out. Now, has that given us any luck? No luck yet. I feel like they are all the way out, but I'll just go over them one more time just to make sure. Now remember, with dealing with things like this, lithium battery packs can be very explosive. Certainly found that out a couple of weeks ago when changing a screen in a mobile phone, and had to try and get the old battery out, and yeah, it got slightly stabbed and nearly went up in flames, but not fully, so we're lucky with that. Okay, so far this is proving to be interesting. We certainly don't. I thought we were going to get a load of sort of 18650s in here, but we don't appear to have that. I'm just having a bit of trouble getting this off this other side. I think when those screws are still holding it in. Yep. And there we are, that's that cover off. So we can remove the screws. And here's the insides. So we've got a massive battery pack there, and we've got cell balancing going out to it from this board, and this is our main little control board. So let's try and get these bits out of the case as best as we can, and we'll have a closer look. So it looks like the battery is going to come out very nicely. This is obviously completely modular design. Oh, that's pretty simple. Yeah, decent size battery pack. We'll try and get this sticker off in a minute, see what's listed on there. And then we've got a couple screws just holding this main PCB in. I don't think anything is particularly sort of blown up that's going to be super obvious with this. Unfortunately, I think it is just something has failed somewhere. So I don't use this for its intended purpose, so I just want to try and recover the what we can out of it. Right, so that's the module taken out, and that's just our empty case there. Okay, so we have a closer look at this little module here. So this is where the output slash input goes out to the battery pack. So we've got this here with 5 wires on, so positive and negative, and our cell balancers. So there must be 3 cells in here. I expect they're just sandwiched in a layer. And so we've got that's the output. Got a little LED here. No real specifications on it, so I don't know how powerful that is. But that's nicely on its own little pull-out part there. So we can salvage that. That could be useful for something. I'm sure the LED still works fine. And we have got the little lens if we wanted it for any purpose. So looking at the board, say there's nothing obvious as to what's actually failed on this. Capacitor looks absolutely fine. No signs of any sort of corrosion or anything. There's a bit of flux residue, but nothing to worry about there. What's going on here? Aha, I think we may have found the problem. Let's have a look closer here. We've got a bunch of resistors here, and this one appears to be missing half of it. Well, that's interesting. Now, was there any bits? I can't see anything in the... Oh, hang about. I think we may have found the problem. Yeah. Alright. See that little part there? So, this little resistor has somehow blown itself into 2 pieces. So yeah, there's our problem. So yeah, we probably could salvage this actually if we wanted to. If we could get another surface mount resistor, or just replace it with a bog standard resistor. So now the question is, do I want to salvage this or not? Let's see if we can figure out what sort of power we've got on this battery pack. A load of sticky foam stuff on it, which you need to try and get off. Be careful if you're doing this with a metal spudger. Just want to see if there's any indication on there as to what this is. We expect a sort of 12 volts output because it is driving, you know, a car battery. So let me just see if we can get most of that rubbed off, and we'll have a further look. Okay, so I've cleaned it up with some IPA and a bit more scraping. So we can see there that we've got 12.8 volts, so that's the nominal voltage of this pack, and it's 25.6 watt hours. A bit annoying, didn't put amp hours on, but it only actually works out at around 2 amp hours. So yeah, they're probably trying to hide the fact that it's not actually that powerful, which probably explains why it wouldn't actually start my car, but it will start sort of smaller petrol based engines. So that's the battery pack, and so back to this main board then. So we've got a bunch of 20 ohm resistors here, and this is the one that is split in half. Now if we look, these are all in line with the output for the charging and the balance charging. So I don't know if something malfunctioned within the cells and caused a spike on here coming sort of feeding back that blew this, or if there was an issue where it's just something with the charging, sort of tried overcharging or something and blew this resistor here. So yes, we could get another S&D resistor, or just get a 20 ohm through hole and stick it across that, and most likely get the thing working. But I've since thrown away the leads for the jump pack side of it, because I don't use that, and it's not a very powerful unit, even though the battery pack's quite big. Say only 2 amp hours overall capacity, but I guess that what you've got is the ability to throw a lot of power very quickly, so it could be quite useful for any kind of e-bike or e-scooter type projects. So I'm not going to bother trying to repair this. We will get rid of that. I will keep the little LED module. It could be quite useful. I'm sure that still works fine, and I'll keep this battery pack. If I could get hold of, I suppose if I go on eBay and grab a sort of 3-cell balancer, could probably balance the cells back out, but I think what I'd do is just feed it directly from the bench power supply and bring it back up to sort of 12.8, 13 volts, and then I can leave it a while and see if it sort of goes down on its own accord without being plugged into anything. But that would certainly explain why it wasn't going to power on. It would obviously charge up and get a false reading, making the assumption that it's fully charged, and when it wasn't, and then of course when you try to power anything, it simply doesn't have the power. Presumably the cut-off voltage for this module, the chip or something in here, the cut-off voltage must be around sort of, we saw it as about 10 volts, so presumably if it loses around 2 volts it won't power this board up. So there we go. So that was a quick video, just taking this thing apart to see what's actually gone wrong. And yeah, if you have one of these units and you've got a similar issue as me, then yeah, you can potentially take it apart without destroying it, replace that resistor, and job's a good one. So I shall recycle this and the LED and the main board. Nothing on here, so that can go to the recycling centre. So thank you very much for watching, guys. Please do give it a thumbs up if you liked it, thumbs down if you don't. Please do leave comments in the comments section below. Please do consider subscribing if you haven't already done so, and please do consider supporting me on Patreon. That would be a great help for me and my channel. See you soon for the next one. Cheers.